Cool. Hey everyone, welcome to our Maple workshop for Math 1B. So there's an attendance form on the slide here, so it'd be really great if everyone can scan it with their phones. Yep, okay, awesome. So this was put together by like a few of us. So it's me, Sky, and Roger. So we're going to go through a whole bunch of different the topics. So we're going to start off with functions of two or more variables. So remember that in Maple treats expressions and functions differently. So an expression assigns a value to a variable where we use like the colon and the equals to define it, whereas a function takes in an input and then it produces an output value and we use like an arrow. We need to use the subs command to evaluate the expression, and like entering like E42 below won't work when it comes to trying to evaluate the expression. So I'm going to put it into Maple and we can see how it goes. So I'm defining A now as an expression. So it's x squared y minus x. As you can see here, like I've defined E as an expression. So I can like differentiate it with respect to x. And then if I want to substitute a value in, I need to do subs x equals 4, y equals 2, and that's subbing into E. And that gives us 28. So alternatively, we can also define it as a function. So we can do f equals x times x and y. And so this map goes to x squared y minus x. So you can see we've defined this function. Oh, okay, yeah, so as you can see here, we've defined this function. And so if we want to like put sub values in, here we go f for 2 for when we have x equals 4 and y equals 2. And that's 28. Okay, so we can also do partial differentiation of expressions, and we can find those using the diff command. So what we want to do is we want to list the expression and then the variables we're differentiating with respect to. And if we want to evaluate the derivative at a specific point, we can use the subs command. If we want to find a higher order derivative, we can either list more variables or use the $ to represent repetition. So let's say, for example, like earlier we want to differentiate, is that typing? No. We want to differentiate x squared y minus x with respect to x. And I typed that in a bit wrong there. Respect to x, like so. And then we can like define it at a point, we can just do subs x equals 1, y equals 2, define it at the point 1, 2. And since we want to sub it into the like previous output, we use the percentage sign. So yeah, as you can see, it's got error invalid input. That's because I just said x minus 1 instead of x equals 1. We can also do, as you can see here in the sample output here, we can also like differentiate like functions like multiple times with respect to both like x and y. And if we want to have the repeats, we can use that $. We can also do like partial differentiation of functions using D. So first we have to make sure we define the function and then refer to the variables by the order they appear in the function. So the first row will be 1, second will be 2, and so on. So for example, like D1f differentiates the function with respect to x, and D2f differentiates with respect to y. So for example, let's define the function, let's define f. So it's in terms of x and y, and it goes to x to the power of 4 times by y squared. And so you can see we've defined our function here. So say we want to do a partial derivative with respect to x, so we've got that 1 there, f. As you can see, it derives with respect to x, and if we have it that 2 in brackets there instead of that 1, we can see that it will differentiate with respect to y. So we can also find higher derivatives of functions using the command D as well. But what we just do here is we list more variables inside the square brackets or use the $. If we want to evaluate the derivative at a specific point, we enter the point in round brackets after the expression. So say we wanted to define that derivative, we want it to do with respect to x twice, and with respect to y twice of f, but we want to find it at the point 4, 2. They can put it in like that, and it gives us our answer. So we can also use Maple to find the maxima and minima of expressions with more than one variable, and we can find the max and min values globally or within a closed interval by using like the 2 full stops between endpoints. We also need to remember to spell maximize and minimize with Z's, not S's, because we have to use the American spelling here. Otherwise it won't work. So for example, we can do minimize with a Z, so you can do minimize sine x plus cos of 2y. And we want to do that in the range x is between minus pi to pi, and y is also between minus pi to pi. And as you see, it'll give us an answer here. Same thing for maximize as well. To plot functions with 2 variables, we can use the plot 3D command. And so what we want to do is we want to enter the expression and ranges for the variables. And then we can click and hold the graph and then like move the cursor around to change the orientation. And so we can see it from multiple perspectives. We can also enter a set of expressions to plot multiple graphs on the same axes. So for example, if we want to do a 3D plot, so you do plot 3D, exp negative x squared times by cos of x plus y. And we want it to go from x is equal to negative 3 to 3, and y is equal to negative 3 to 3. And so it plots it for us, which is really nice. And so what we can do is we can spin it around, have a look at it from multiple angles. We can also plot multiple graphs on the axes, and we just enter them in as such here. But instead of the one input, we can input them as like a list. So undo those, and then say we also want to plot y equals x squared. Is that not liking it? Let me see, I'll put in a different function. So we can do sine of x plus y plus 13x y. And we can see how it plots both of those functions on the same set of axes, and we can also like manipulate it to like spin it around and have a bit of a look. So we're now going to move on to the further calculus. So when integrating, it's often useful to simplify expressions into partial fractions. And so if we want to do this in Maple, we can use the convert command with the parfrac option. So what we want to do is we also need to list the variable you're simplifying with respect to. For example, here it's x. So what we can do is we can convert 1 over x squared minus 4 into partial fractions. So we put it in like that. So we do parfrac, and then with the variable we're doing it with, and I typed that in wrong. Parfrac, and then it puts it into partial fractions for us. And so now often we want to integrate it, and so we can do int, we can use the percentage sign with respect to x, so percentage sign takes that previous output, and then it will integrate it for us. We can also use Maple to solve differential equations using the dsolve command. So what we need to do is we need to write the subject of the function as a function of the independent variable, and in this case we'd write y like brackets x instead of y, otherwise it won't work. And so then we write the equation followed by yx, since y is the function we're trying to find. So for example, if we're doing y dash plus y equals cos x plus x, we can define that as ODE ODE 1. So we want to differentiate yx x plus yx is equal to cos of x plus x. And as we can see here, it's exactly what we want. And it's always good to check like the output after you enter it in, just to make sure. And so then we can do desolve of ODE 1 for y of x to solve the differential equation. And that's our solution with a constant at the end. We can also do the same for higher order differential equations, only for like y double dash, it's like diff y like x, and the rest is all the same. And then we just do desolve again. We can also use desolve to solve differential equations with an initial condition. So what we do is we enter the conditions as a set of equations inside curly brackets. For example, y dash plus y is equal to cos x plus x with the initial condition y of 0 equals 0. So here we can define this as ODE 4, and so that's diff y of x plus yx is equal to cos of x plus x. So that's our differential equation. And what we can do is now we do desolve. And so what we're going to do is we are now like normal, and then we put in our initial conditions. So equals 0. And we need to close that bracket. And then we do y of x. And it solves it with the initial conditions, as you can see here. We can also do initial conditions involving derivatives, but we have to make sure to position our brackets correctly. As you can see here, the condition y of 0, we need to enter it as dy0, but dy like 0 with the brackets like this. This won't work, but this will. Sorry, but this will. So for example, with that differential equation there, what we can do is we can enter it in as ODE 5, and so that's equal to diff y of x, so we're going to do double derivative diff minus 2 times y of y x equals x, so we enter in our differential equation, and then we do desolve to solve it. And so here we're entering in our initial conditions, so it's minus 0, 0. We also have dy of 0 is equal to 1. Like so, and it solves it with respect to all of our initial conditions. We can also find the limit of convergent sequences and series using the limit and sum functions in Maple if we know an expression for the nth term. So what we can do is we can find the limit for a sequence where the nth term is 1 over n plus 1, and we can also find the sum like this here, and then for that we'd use the sum function first and then the limit function. So for example, if we're going to find the limit of a sequence where the nth term is 1 over n plus 1, we can do limit 1 over n plus 1, and that's n equals infinity. Oh, we've got an unexpected bracket somewhere here. Here we go. There we go. So it would be 0. And so here we want to do the sum of 1 over 2 to the k from k equals 0 to n. And so that gives us that sum there. And then if we want to find the limit of what we had previously, and for n is equal to infinity. So we can put that in there and it'll find it for us. Okay. So we can also use the Maple's Taylor function to do stuff with Taylor series. So what we do is we can just use the function Taylor. So if we want to do exponential x, so it's like we can put x equals 0, 5, like so. Oh, we're missing, sorry, my mistake here. Exponential x, and as such we can see that Taylor series. If we want to convert from a Taylor series to a polynomial, what we can do is we can first define this s as Taylor xp negative x times by sine x. That's for x equals pi on 2 to 8. I'm going to close that bracket here. So it does that, but we want to convert it to a polynomial. So now we're going to use p. And so we're going to do convert s and then polynom. And it converts it to a polynomial. Okay, so now we're going to move on to the further linear algebra topic. So as you can remember, we're going to start off looking at vector and matrix operations. So if we want to multiply a vector by a scalar, we use the star, and to add and subtract vectors or matrices, we use plus and minus. However, only vectors and matrices of the same size can be added. To multiply vectors and matrices, we use a dot. Square matrices can also be raised to a power using the caret symbol, which is this symbol, and the determinant and inverse can also be found. And so this is just an example here of a couple of vectors and a matrix. And so you can just use like the operations that I explained to do them. So for example, we're going to put in v is equal to 1, 2, 3, and w equal to w is 4, 5, 6. And so as we can see here, we can do, so we can't do v times w, but we can do v plus w, like normal matrices. And if we want to multiply it by a scalar, we can do like 2v is equal to 2, 4, 6. And so we've also got a couple more examples. So we can also find like the dot product of v and w by doing v dot w. So that's 32. And if you want to find the cross product and dot product, we need to make sure we use with linear algebra. Oops, forgot to put in that colon there. With linear algebra, and so then we can do that cross product of v and w and dot product as well. Okay. We can also use Maple to find out information about a matrix, for example its kernel and rank. So we can use functions like dimension, row dimension, column dimension, rank, basis, row space, column space, and null space. And we always have to remember that we need the with linear algebra to start off with. So for example, we've got our with linear algebra up here. So we're going to define matrix A to be the matrix 1, 2, 3, 6, 7, 8, 9 as such. So we've got our matrix A. So what we can do is we can find its dimension, and then the column dimension, row dimension as well. We can find its rank. And we can also find its row space, column space, and null space. We can also find the eigenvalues and eigenvectors of a matrix using Maple. And we need to first load the linear algebra package and then enter a matrix. So for example, we're going to assign this matrix now to be B. So we're going to go just B, and so that's 0, 0, 1, 0, 1, 0, 1, 1, 0, 0. And so what we can do with this one, we can find the eigenvalues of B and the eigenvectors as well, as such. Okay, and so now I'm going to hand over to Roger, who's going to take you through the other two topics.
Okay, so the next topic we're going to cover is 3D geometry and how we can use Maple to kind of like simplify the chaotic mess that is 3D geometry. So first, just a quick point back to what Isabella was talking about the dot and cross products. We can find them by using Maple's linear algebra package. Just one small note to add: when we're using the cross product, we have to make sure we have to be very careful about the order of vectors that we put in. So the cross product of UV would be different to the cross product of VU. Okay, now let's talk about the package. So the Geom3D package is a really useful package, and we can call it by entering with Geom3D. Okay. One of the main benefits of the Geom3D package is that it allows us to define many different types of objects, including points, lines, planes, spheres, and some other objects, and allows us to, for example, find the intersection points of the, or find the angle between them. Okay, first thing we're going to cover is how we can define points using the Geom3D package. So because we want to define a point, we tell it we're going to define a point, so we do point bracket, and we have to give this point a name. So let's call this A, and we have to give it the coordinates. So I have a point A with coordinates, let's say 1, 1, 1. And then Maple has defined this point A. Now, let's say supposedly we've forgotten what A is. We can use detail to uncover information about it. So we know that its name is A, it's a point, and it has coordinates 1, 1, 1. Now, for defining lines and for defining all these other objects, the procedure in which we do it becomes a lot more varied. So there's several ways we can define lines in Maple. The first one is to define a line as a line that connects 2 points. So we've already defined a point A. Let me define a new point B. So I'm going to do point. I'm going to call this new point B, and I'm going to let it be 1, 2, 1. Now, I can create a new line. Let's call this L, that passes through AB by doing line bracket L. So the L is the name of my line, and A, B are the 2 points that my line passes through. And just like what we did with point, we can also use detail to find some information about the line that we've created. So we found that its name is L, it has a form 3D line, and we can also find its equation x equals 1, y equals 1 plus t, and z equals 1. Now, the second way we can define lines is by is kind of analogous to the way we define vectors, lines using vectors. So we give it a point and we give it a direction. So let's create a second line. Let's call this line L2. And remember, for the vector representation of a line, we need two things. We need a point that the vector passes through. So in this case, I'm going to use A. And we need a direction. So in this case, I'm going to use B. Let's use a different one. Let's use 1, 1, 1. Okay. And here, Maple has created the line for me. And if I check the detail again, I'll be able to find its equation of the line. Okay, the third way is kind of going in reverse. So instead of giving it the point and direction, we give it the parametric equation. And I won't cover that. Okay. Okay, the next object that Maple allows us to create are spheres. Now, something we might have started to notice by now is that the way we declare all these objects is the same thing. We start off with what the object we want to create is. So in this case, I want to create a sphere, so I'm just going to type sphere. And then after I type sphere, I'm going to enter some information about that object inside the bracket. Yep. So there's two different ways we can define spheres in Maple. The first one is by giving it 4 points and telling it the center. Because if we choose any 4 points, there's one unique sphere that passes through those 4 points. So that's the first way we can define a sphere. The second way we can define a sphere is by giving it 2 points, which Maple will implicitly assume are the endpoints of the diameter. So in this case, let's restart this. Let's import our package with Geom3D. Now, let's define 2 points. So since the point, I'm going to have to use point. So this is point A, and it's going to have coordinates 1, 1, 1. Similarly, I'm going to create a second point B, and I'm going to give it the coordinates 1, 5, 6. Finally, to create the sphere that has a diameter between these 2 points, I'm going to use sphere. I'm going to call my sphere S, and it's going to go between A and B. And we can use detail to find some information about the sphere. It has a center 137, it has a radius of root 41/2, and we can also find its surface area, volume, and even the equation of the sphere. Now, let's see. The final kind of like mainstream object that we're going to cover are how to define planes. So the first way to define planes is by giving it 3 points that the plane has to pass through. So let's first define a third point, C. It's going to pass through 9, 8, 7. And we can create a sphere. Let's call this sphere P for plane. And it passes through my points A, B, and C. Let's use detail to find some information about it. We can see its name, we can see what type of object it is, and we can see its equation of the plane. Okay, the second way to define a plane is by using its point normal form. So we give it a point that the plane passes through, or we give its normal. So let's start off with plane because we're creating a plane. Let's call this plane P2. It's going to pass through the point A and has a normal vector of, let's say, 1, 1, 1. And let's use detail. This plane has equation 3 minus 11x plus 40y minus 32z is equal to 0. Okay. So that's planes. We can also define a couple of other objects in Maple, except our use cases for these objects will be like much less frequent. One really cool object that we can define is a triangle. So we can create a triangle. Let's call this triangle T. To define a triangle, we have to give the triangle 3 points that the vertices lie on. So in this case, I'm going to use my predefined points A, B, and C. We can use detail to find a bit of information about it. So we know it. We can kind of like track its 3 vertices as we go on. Okay. There are many different ways to find out information about an object. General command for this is detail, as we've been using throughout this talk. For the equation of an object, we use the command equation. So let's say we want to find the equation of P. Equation of P2. Oh, we need capitals. So let's find the equation of P. This is x, y, z. Yep. This is 3 minus 11x plus 40y minus 32z. And to find the coordinates of a point, we use coordinates. Okay, now this is one of the probably the most it's probably the reason why we would want to use this Geom3D package in the first reason, and that's because it allows us to find the intersection points of multiple objects in Geom3D. So let's restart this. Restart. Okay, and let's include the Geom3D package. Now let's create a couple of objects. So the first object I'm going to want to create is a point. So point A. It's going to pass through 1, 2, 3. I'm I'm going to create another point, going to call it B, and it's going to pass through 4, 5, 6. Now, I'm going to create a line that connects, that passes through these 2 points. So this is line, let's call it L, and it passes through A, B. And let's also create a sphere that passes through these 2 points. So we're going to use the command sphere. Let's call this sphere S, and it's going to pass through A, B as well. Awesome. Now let's find the intersection point between these 2 objects. So to find the intersection point, we use intersection. Now we have to call these intersection points, we have to give them a name. So let's call them G in this case. So we're going to call the intersection point G, and we're trying to find the intersection point of L and S. So we pass those in. Okay, so we find that there's 2 points of intersection, and to find what those 2 points of intersection are, we use detail. So we get that the first point of intersection is at 1, 2, 3, and the second point of intersection is at 4, 5, 6. Okay, awesome. Now, another really nice application of Geom3D is that we can plot geometric objects. So let's plot, and we can even choose colors for the objects that we're plotting. So to plot things, we use the command draw. So we're going to draw this, and let's draw just S. Remember, S is the sphere I've created. And it creates a sphere. Now, things we can do with this is we can specify what color we want the sphere to be. So we have S, let's give it the color, let's do pink. And that creates the same sphere, but in pink this time. Okay, some other useful properties of Geom3D is that are like finding angles and distance. So distance finds the distance between 2 objects whenever it makes sense, and finds the angle and radians between a plane and a line. So let's go through each of these one by one. Let's begin by defining a plane. So we have a plane. Let's call this plane P, and let's define it using its point normal form. So it's going to pass through A and have a normal 1, 1, 1. Okay, now let's find the angle between my point P and my line L that I've already defined up here. That is pi over 2. Now I wonder if distance will work on these 2 objects. Let's find the distance between P and L. 0. Which probably means that they intersect. Yeah. Okay, that's it for 3D geometry. The final section of today's talk will be about programming in Maple. Now, the whole idea of this topic is that we can translate ideas from programming into Maple, for example, loops, conditional statements, and procedures. The advantage of this is that it allows us to evaluate long expressions which would be tedious to do individually. These ideas are inbuilt into Maple, meaning we don't have to import any packages. Okay, so for those of us who haven't done coding, when we use the word procedure in everyday life, it just means a series of actions. For baking a cake, you'd follow a procedure. For evacuating a burning building, you'd also follow a procedure. We can think of functions as procedures because they take in a number and then perform a series of actions on that number. This gives us 2 ways to define functions. The first way being the way that we're accustomed to, so giving it a name, f, that maps between, let's say it maps x to x squared. This is the first way of defining a function that we're kind of like accustomed to. The second way of defining a function is using procedures. So just like before, we start off by creating a new function. Let's call it g. But this time, instead of like using this like arrow symbol, we use proc. So we're going to use proc x. So we're saying this is a procedure in terms of x. And what it's going to do to my x is that it's going to double it. And because that's the only action I wanted to do, I'm going to end off with end proc. Now, no matter, let's change this one to 2x. Now, regardless of the way I define the function, the the way we call it is the same way. So let's call f of 3, that's 6. I could also call g of 3 in the same way, and that would also be 6. Okay, the advantage of defining functions as procedures is that it allows us to perform multiple actions on the number we put in. For example, if we want to double a number, square it, and then add 1, we can use the following procedure. So let's call my procedure h. It's a procedure, so I'm going to start off with proc x. It's going to take in a number, it's going to double that number. That's my first action. Now, to move on to my next action, I first have to put a semicolon. Now, I'm going to take the result of the 2 times x, and then I'm going to square it. So to access my last result, I'm going to use the percentage sign. So I'm going to raise my percentage sign squared. So that's me squaring it. And finally, to add 1, I add another semicolon, and I do percentage plus 1. And since I'm done now, I need to end proc. So let's try h of 3. It's 37, which if we double check it, let's start off with 3, we double it, we get 6, square it, we get 36, and add 1, we get 37. So this is right. Okay, the next thing we're going to talk about are Booleans. So far we've only really used Maple as a calculator. However, we can also use Maple to evaluate the truth or falsity of mathematical statements using eval B. So a lot of us hopefully are accustomed with eval f. So what eval f does is that it just gives us the numerical value of whatever we're trying to find. For example, if we want to define what pi was, we just put eval f pi, and it gives us 3.141592254. In the same way, eval b kind of finds the truth of a mathematical statement. So let's define x to be equal to 6. Let's evaluate the truth of whether x is greater than 3. It's true. Hopefully we all knew that was true. Yep. But we can use, in this example, it's not really helpful to use eval b, but for more complicated expressions where evaluating is a lot more tedious, we can use eval b to kind of take a shortcut. So let's say I wanted to know whether 100x minus 99x minus 98x is greater than 0. To do that, I'd put eval b 100 times x minus 99 times x minus 98 times x is greater than 0. And Maple is telling me that this statement is false. Okay, now we're going to talk about conditional statements. Sometimes we want Maple to make decisions based off the input we give it. We can do this through using conditionals. The syntax of a conditional statement in Maple is if condition. So let's say if this condition happens, then we want to do this. Okay, let's write a program together that finds the circumference of a circle with radius r that rejects any negative radius. So let's restart this. Okay, the first thing I'm going to want to do is create a function. Let's call this circumference. And I'm going to define it in the same way we define a procedure. So this is proc r. Now, before I calculate the circumference, I first want to check whether the radius that we've given in is positive or negative. And to do that, I can use a conditional statement. So to start off my conditional statement, I use if. So if, and I need to think about my condition. My condition here is if my radius is less than 0, then what do I want Maple to do? I want to return to me error negative radius. I'm going to end my conditional statement here. Then I'm going to return the circumference, which is 2 times pi times r. And end proc. So let's try and find the circumference of a circle with radius 5. This is... why is this not working? Return 2 times pi times r. Oh, it needs a capital C. That's 31.415924. But let's say we wanted to find the circumference of a circle with radius negative 2. Maple would return to us error. We have a negative radius because of this if statement that we've nested at the top. Okay, one of the final things that we're going to cover today are loops. We can use loops to evaluate long expressions. The general syntax of a loop is for I from, so I is kind of like a dummy variable that we're working with. So we have to give I like a starting point. So let's say like where I starts from, and then we have to tell Maple how much we want to increase or decrease I by. And finally, we need to tell Maple like when to stop the loop by giving it the endpoint. Now, we actually like, then we need to like tell Maple like what we want to do with like the value of I. So we tell it do whatever you want it to do, and then end do. For example, to find the sum of the squares from 2 to 20, we could write. So let's restart this. So we start off by giving Maple our starting point. So for I from, we want to start at 2. So for I from 2, then we need to tell Maple how much we want to increment it by. So we want to find 2 squared plus 3 squared, so we want to move up by 1 each time. So I'm going to, for I from 2, by 1, and then we need to tell Maple when to stop. To 20, we want to do, or before we do all that, we need to first create a variable called total. Total kind of just like keeps track of the sum as we go. Do total is equal to the original value, existing value of total plus I squared. So I is like a number between 2 and 20. Total is this current sum. Do total, and then end do. So yeah, it evaluates the sum. Okay, now let's work through another practice problem for loops. Suppose we have a set of prime numbers 2, 3, 5, 7, 11, and 13. How do we evaluate the sum of these prime numbers squared? At first, we might want to, like, we might think about using sigma notation because we have like a sum and we have like kind of like all of these like numbers are squared, but we can't use it in this case because there isn't a consistent pattern between the primes. So our solution is to use loops. So first I'm going to begin by defining a set called primes, and it's going to contain the prime numbers that I want to add. So 2, 3, 5, 7, 11, and 13. Then I need to use a loop. So let's start off with total is equal to 0. For p in primes, so for any number in primes, we want to do total is equal to my existing total plus the prime number squared, and do. Oh wait, we need to do these in the same line. So let's define primes down here. This is 2, 3, 5, 7, 11, 13. Maybe we need a semicolon here? Nope. Okay, well, there's a small mistake in the code here. I can't really figure out where. But this is a general kind of like way we would approach the problem. Ah, yes. Yep. So we forgot a semicolon up here in the very first line. And as we can see, our program is going to loop through primes and slowly add the value of each prime number squared. So we're going to start with 0, add 2 squared giving us 4, adding 3 squared giving us 13, and so on and so forth. Okay, now this is the final kind of like slide of today. It's all about putting everything together. We can combine all of these ideas together, loops, conditional procedures to create programs. As an exercise, let's create a function that takes as input an integer n and outputs -1 if the integer is negative or 0. If the integer is positive, the procedure should output the sum of the integers from 1 to n. So first, we're trying to create a function, so let's use procedures. So let's call this function f. It's a procedure. Now, it takes an integer n and outputs -1 if the integer is negative or 0. So the way we want this program to run depends on what value of n we put in. So that's telling us we should use a conditional statement. So if n is less than or equal to 0, we want to return -1. And if otherwise, for I from 1 to n, do total is equal to, we need to define total at the very top. Total is equal to 0. Total is equal to the pre-existing sum of total plus the value of I. So a number between 1 and n. And n do. Parameter end of input. Oh wait, we also need n proc because we're at the end of our procedure. Okay, let's test it out. So let's find the f of 5. This should give me the sum of all numbers from 1 to 5. But let's see if it evaluates f of 0. Note, for f of 0 it gives us -1. What about f of -5? It also gives us -1 because 5 is a negative number. Okay, that's it for today. Hope you guys enjoyed.